Hi, I'm Caroline, and in this video, we'll look at what atom economy means, why it matters for both exam questions and real-world chemistry, and how to calculate it from a balanced equation. You'll see that the maths is simple once you know what you're looking for, no scary rearranging of equations required. And if you find this explanation clear and helpful, then hit like and subscribe right now. Okay, let's dive in.
Let's start out with what is atom economy? What does it mean? Well, what it looks at is if you are doing a chemical reaction as a chemist or in any other profession, then you are usually doing it for a purpose. You are doing it in order to make something that is what you are considering useful. Anything else that is made is not necessarily useful for you. It's waste. We don't need it. So what atom economy does is it looks at what percentage of all of the products that are made are the actual desired useful product. So here's the equation for calculating atom economy. You would take the mass of the desired product in the equation. And remember, desired is defined by us, like the humans that are doing this chemical reaction. Why are they doing it? What makes it useful for them? You then divide that by the mass of all reactants in the equation. Now, this is the most strict definition of atom economy. It is the definition of it. In practice, the mass of all reactants equals the mass of all the products because of the law of mass conservation. But if you are asked for some reason, like what is the equation? It's this. It's mass of all the reactants in the equation. And that's how you're going to see me do this when we do some worked examples in a moment. Because this is a percentage, you would then times that by 100. Now, the higher the percentage atom economy, the less waste we have to get rid of. So for example, if something has a 70% atom economy, it means 70% of the product is what we want. It's desirable. We can sell it and make profit. 30% of it would be waste. If you are lucky enough to be doing a chemical reaction with only one product, then the percentage atom economy would be 100% because every single atom that in the reactions would end up in that desired product. Here are some common mistakes. So oftentimes people actually don't have a clue how to answer these questions because unlike a lot of other calculations, then you don't get given the numbers. It will say calculate the percentage atom economy for this question. What you have to remember is you have to use the periodic table to work out the relative atomic masses or relative formula masses, and these are then the masses that you use for your calculation. This is then the only time that you use the big numbers in this way, because once you have your relative atomic masses, the ARs, or the relative formula masses, the MRs, you then times them by, multiply them by the big numbers that were used to balance the equation. You never normally do that with an AR or an MR. So please literally compartmentalize this in your brain. When it comes to reacting mass calculations, limiting reagent calculations, etc., you never do this. It's only in atom economy, and I'll show you what I mean by that when we do an example in a second. The final point is especially relevant if you are an A-level student watching this. You might need to consider the significant figures because oftentimes at A-level we're looking for, are you giving your answer to the appropriate number of significant figures? Well, in which case you'll need to look at the significant figures of the ARs or the MRs that you are working with. Taking special note if you are using hydrogen, because that can often limit the number of significant figures to 2, when most others might be 3, etc., or even 4.
So what we're going to start with here is by working out the total mass of the reactants. The reactants here is just glucose. So looking at the periodic table, I'm going to look up the AR of carbon, hydrogen, oxygen, and then add those all together to make the glucose. So I'm going to do 6 times 12 plus 12 times 1 plus 6 times 16. That gets us to 180
and we consider that MR its mass, 180 grams. Then I'm going to work out the mass of the desired product. It says ethanol can be made by fermentation using glucose. It's the ethanol that is the whole point of why we are doing this reaction. It's a desirable, useful product. So I'm going to work out the MR of that ethanol. I have 2 carbons, 2 times 12, plus 6 hydrogen, 6 times 1, plus 1 oxygen, 16. So 2 times 12 plus 6 plus 16, and that gets us to 46. However, I have a big 2 here, so I'm going to times that 46 by 2. And remember, this is the only time you are allowed to do this with the big numbers, and that gets us to 92 grams. To work out the percentage atom economy, we therefore do the 92 grams divided by the total mass of the reactants, the 180, times that by 100 to get a percentage, and that gives us 51.1%. Remember, if you are an A-level student, think about the significant figures. 180 is 3 sig figs. 92 might be 3 sig figs, because if you look at your periodic table as an A-level student, often your ARs are given to 1 decimal place. I have used a GCSE one, which is why I've got 180 and 92. You might have a different number of significance figures. Okay, so starting the same as we did before, we're going to work out the MRs of the hydrogen peroxide and the oxygen. Our hydrogen peroxide is our reactants, our only reactants, and we're told to form oxygen. That is our useful desired product here. So to work out the MR of the H2O2, the hydrogen peroxide, we're going to do 2 lots of 1 for the hydrogen and add that to 2 lots of 16 for the oxygen. That gives us 34. There is a big 2 in front of that hydrogen peroxide, so we have to times that by 2 to give us therefore 68 grams. That's our total mass of reactant. Now let's take our desired product. So to work out the MR of the oxygen, it's 2 16s, which is 32 grams. Now to work out the atom economy, we do 32 divided by the 68, times it by 100, and we therefore get 47%. Again, noting that I have done this to GCSE significant figures, and A-level students, you might have a different number of sig figs because you work with a slightly different periodic table.
Thanks for joining me today. If this was helpful, hit like and subscribe now. And let's boss your GCSE or A-Level chemistry exams together. I'll see you in the next video.